just shout, so his mic will pick me up. We have Suryansh Kumar from Symantec. We also, November 12th, we have Tom Limoncelli, who's Chief Site Reliability Engineer for Stack Overflow, coming. That's an exciting speaker. Next week, we have Michael Race, who is a top New York City DevOps recruiter, coming in. He's going to talk about what kind of jobs there are in DevOps and what you can do with the knowledge you gain. But Suryansh, please, you begin. Thank you.
All right, so who am I? I'm first year grad student. Before coming here, I was working with Norton for 2 years. I did my undergrad in India. That's my undergrad university in IIT Suratko. You can call me Tintin, it's like an easy name which everyone calls me. So Symantec is the big company, it's like a huge name in the cybersecurity space. Norton was an independent company product, mainly for Windows utilities and things like this. They started out with an antivirus product and Symantec bought over. So Norton is now under Symantec. Okay. So what I'm going to do today, I'm going to tell you a bit about the product and what the old process of development was. It's been around for at least 20 years or more. So we're following the waterfall model for a long time. Agile and DevOps, they became like buzzwords which everyone was catching on to. So we decided to do some changes, move over everything. So there were some proposed changes. I'm going to tell you what the perceived benefits were when they thought, what was the rationale behind making that change from Agile towards DevOps? What were the steps involved in the execution of the change? And the main thing was the adaptation issues and resistance. Because like we are trying to tell them to change everything what they've been doing for like 10, 15, maybe more years. There's a certain way of doing things, there are certain processes which have been in place. And then we are trying to ask them to move away from all of that. So there were a lot of issues with adaptation, with a lot of resistance from people. Was it worth the hassle? I'm going to discuss about the cost benefit thing over here and some concluding notes. At any time you want to ask any question, feel free. What I'm not going to do is go into the technical implementation details because that varies between company and company, how each organization is implementing things. The systems in place, if it's a third party thing, is it something they took a contract from someone else, something they built from scratch. So I'm just going to go like a high level overview and just talk about the processes in general, not the technical stack which we used. All right. So Norton antivirus, it is used globally and shipped in over 30 languages. Okay. It's massive. It's among the biggest products in the world in cybersecurity, like product. So we have consumer security, we have enterprise security, and in consumer we have a separate one for each Android, iOS, Windows, Mac. I was in the Norton Windows team. So each of these products have a different, of course, build process, different developers. So we try to keep feature parity and make sure all the features come out at the same time in each of these, as long as they're compatible. But they have like different release streams altogether. So I was in the Windows thing, and this runs from all Windows versions from XP, Vista, 10, and over 32-bit, 64-bit, and it's massive, like 10,000 source files. When I was in undergrad, I thought a big project was like, okay, we have like 30, 40 MB of code files, and that's like the biggest thing. We made some games and stuff. When I saw like 10,000 source file, it was just like a very different scale altogether. And yeah, so imagine each product, we have different offerings based on the pricing. We have Norton Security Premium, we have Norton Security Deluxe, we have Norton Internet Security. Some of them are bundled with like Chrome extensions, Firefox extensions for browser protections. There's like various different offerings, and based on them, and imagine each of them running on different OSs, different architecture, 32-bit, 64-bit. There's like a lot of code which is very specific to only one sort of OS and one sort of architecture. And since this is a security product, right, we need to test it more thoroughly than we would a normal product. So if you have like a normal user-based site which does not involve a lot of consumer data or like PII, personal identifiable information or things like that, which is not very critical. So people can take it a bit relaxed while testing it, not do it as extensively. But over here, testing is extremely vital because other applications like the OS are dependent on us to keep them safe. So we need to do everything we can to make sure there's no bugs, there's no vulnerabilities. Of course, every single product has bugs. Like I've heard Facebook, there are like 3,000 bugs reported every month. But they don't need to fix all of them because very small customer segment would even interact with that. And based on the priority, based on the business needs at that point of time, any organization can like deprioritize them. So it's the same here, but like whenever it comes to security related things, it becomes a bit, we need to fix it as soon as possible. Right. So what a test case is, I guess we all know, but I'm just going to iterate what a test case meant over here. In Norton, you have a Windows application, an exe which starts, okay. So there's an install flow where you click on the exe, you click the install, select install directly, go ahead, that's like one test case. So we have like multiple test cases, you right click on a file, do a file scan, update these things. Each test case needs to be executed across a combination of Windows versions, architecture and localized language. So what this means is that we have a test case, but to be entirely sure that it's not failing across any of these different OS and architecture specifications we have, we need to run them all. So at the bottom we say a context. We call a context as one single combination of an OS. Win 10 RS4 32-bit Japanese, Win 7 64-bit German. So if one test case is failing specifically in a single context like this, then you know that, okay, the code related, maybe there's something related to the OS, or maybe there's some localization issues with the language over there, okay. So I'm just trying to tell you about the scale. There's 10,000 source files. There are close to like 30 languages across so many different OS versions and architecture. There's multiple combinations. So testing it is massive. Testing it is huge, all right. So we had a very old waterfall process. We had like a dev team of about 100 to 150 people and like a large QA team. They were working independently. Release cycle of about 6 months. So we used to have biannual releases, like a lot of old products you'll see. Even Windows right now, it's like 2 times a year, the release cycle. So it used to be like that. Initial months, we'll do all the requirement gathering, architecture, all the initial steps, and the developers would be busy, and they would only start working when everything is final. And after it was complete, then the QAs took over and tested. So initially, developers are kind of busy, QAs are kind of having fun, and then it used to reverse. Okay. What would the QAs do? They would manually go through. So all the test cases I told you, right? There are close to 8,000 test cases, and to execute it on a single context, it would take from 5 minutes to 30 minutes. If you're doing something like a full system scan, where you're scanning the entire hard drive, everything. So a QA person will actually execute it on one of those OS contexts and wait for it to end and see if there's no issue and collect logs if there are. So it was kind of inefficient, but that was what the QAs were for, like for testing all these manually, okay? So what would happen when development started and then, you know, we have a new requirement. So the features which were there, which were fixed as in waterfall, they would just like, it would be very hard to put them in after you've done the initial phase, right? So we would mostly have to wait till the next release to put any new feature in, okay? And because of this, there was a slower turnaround time. It was hard to keep up with competitors. A lot of these features which we develop, right? Of course, they are used for protecting, but they are also, we do them for these people called the security reviewers, the product reviewers. So there are a lot of these in the market. They'll be comparing different versions of different antivirus products, and they would be giving us a rating or a score. So only the extremely tech-savvy people would be using. Less than 1% of our consumer base would interact with those features. But they would, you know, change the rating, and then that would end up, you know, changing our sales, because they will say, oh, this security reviewer gave us this score, maybe this other product is better, so we need some feature parity. Yeah.
One of the competitors, in a sense, you're trying to keep up with is the people making viruses.
Yeah.
And they're certainly not going to say, oh, they're on a 6-month cycle. Let us wait 6 months to
Exactly.
release our new virus so that Symantec can keep up.
Yeah.
So you're competing with virus makers who put them out as fast as they
Yeah.
want.
So the security engine, the security technologies used in the backend, they're kind of similar across the Windows, Mac. If they're browser-related threats, they're same. And the product interacts with the OS, that which sits on the top of the operating system, it is different across each OS. So there's a separate team which handles all the security related, complete different organization. But how they interact with the Windows operating system or the Mac operating system, it's based on the, it depends on the product developers. They are the ones who control how to use the security technologies and make it work with the Windows or the Mac or the Android team. Okay. So yeah, launching a new feature like next month or next week, where it appears in the market as this very new thing which came up with one of the competitors, or like a new virus came up. So we can't really, it was kind of hard to like put it in. Of course, there were ways to do it that time. We can't just wait for 6 months if a virus is out. But it was like not as seamless, and it wasn't what everyone did all the time. Maybe a few people would be well versed with the entire architecture of the product, and they would be like, okay, we need to change A, B, C, and we don't need to touch these things, so we can keep this out faster. So this was the old process. And what was the change proposed? So the changes, apart from the technical aspect, there was also a lot of management push, like a very a change in the processes of how the organization functioned as a whole. The chain of command, the hierarchy, there's a dev manager, there's a QA manager, they handle dev teams, they handle QA teams, and above managers, there are senior managers, maybe VPs, directors, and those kind of people in the tech side. So what was decided was that the entire dev team of engineers, they're called individual contributors, if you're not aware. That's a term used for people who are like start out as a tech person, as an engineer. So they would be divided into smaller scrum teams of size 5 to 10. And each scrum team would own one feature, like something like a file scan is like one feature, backup, which was like a new offering, so that was handled by a different scrum team. And it's a small scrum team. Okay. The QAs, they were transitioned into other agile roles, like the scrum masters, product owners, or they joined dev teams. So why was this done? Because DevOps and agile, all of this is based on a lot of automation. So we have a lot of these test cases which were manually run, and we needed to automate them in order to actually be somewhere close to agile or DevOps or whatever in between thing which our company was trying to achieve. Because every company does it different, every organization, every product has its own idiosyncrasies, and you can't really follow like a certain textbook model of thing everywhere. Okay. So from like a 6-month release cycle, we called something like a 3-month cycle, and it's called a product increment. We have like sprints of 2 weeks. A product increment was very different from an entire 6-month release cycle before, in the sense that you could release features in between a product increment as well, like consider a quarter, like from January to March. So it was possible that we get to know about a feature, we start developing in 1 sprint and 2 sprints, and we put it out. So 1 sprint is 2 months. That was fixed. Sprint time is fixed, the product increment is fixed. So we have 6 sprints in each product increment. So every 3 months, 2 months, 2 weeks, 2 weeks, 2 weeks, that's like 1 sprint. So we could like start planning for 1 sprint. Okay, we need to get this feature out in 1 sprint, and half sprint we'll be testing it out, and then we'll be pushing it out. So it became kind of easier. It was flexible, at least in theory. The idea was that we could like release things faster now. Okay. So based on this, yeah, faster releases were possible, and the main thing was like, now that we are going towards agile and we want to depend on automation, we don't really have the automation of entire testing of 8,000 test cases in place, right? We're just starting the journey. We are making all these changes, but a lot of it depends on this automation, right? So who's going to be doing it? So it was a responsibility of the same dev team now. So there was a huge backlog. Whatever manual testing is going on, we'll be converting them to automated scripts. We will be using Python or whatever. Each user scenario would be, there's a script which would actually interact with the UI, and that would be deployed, and that would run across each context. So you just write one script, you develop it for one test case, maybe like an install flow. Then you execute it, and then it would go on the cloud, and it would run across all contexts, like Win 7, Win 10, Win 8, 32-bit, 64-bit, Japanese, German, everything. So you just like write it once. So we had to do this for all the 8,000 test cases which were being run manually by now, till now. Okay. What was the benefits? Like I mentioned, faster release cycles. No need to rely on manual process of testing. So humans might miss out things, right? Humans were being, they were doing testing for a long time, but bugs would still creep in, and that happens all the time. So we thought, okay, it would become a bit efficient. Humans might miss out things, but if a set script is doing it, it can collect logs and analyze the logs at a faster time, and humans might miss something which the system might not. So more efficiency over there, and we'll be saving a lot of developer time and engineer time, because like we need to pay all these people who are doing manual testing, right? Like it's a huge number of people. That's a cost to the company, and gradually as we automate, automation was taking up some jobs, but we did a lot of realignment. We didn't like fire people like that. Wasn't like it didn't happen to that extent. They were like given different roles, but in the long run we would be saving a lot of money, because we won't have people spending so much time for each and every single release, for each and every single feature, doing things manually. Okay, so we would save the cost, and it was perceived that the quality of code would be, because will be constantly testing them while they're under development. So the features would be, they'd be of higher quality constantly throughout the process. We won't be like developing something and then doing an extensive testing at the end of the entire cycle of 3 to 4 months. When it was 6 months, maybe 3 to 4 months of development, and then we test it extensively across, give the build out to the QAs, and then they find out defects, and then it becomes kind of hard to fix. So constantly we'll be testing them. An automation system was not in place yet, but when it would be testing it while we're developing. So any issue, we'll be notified it, we'd get the feedback within maybe the next few days or the next week, and then we could go back and then change it. So which is very good, which is like a very positive thing. And it was earlier to work on time critical requirements and emergency fixes. So like he mentioned, there's a lot of people putting out viruses. So when this was in place, ransomware came out, Spectre meltdown vulnerability, and then we were able to like instantly, within like few days, a couple of days, we would send out a hot fix to all people, like an emergency update, and we actually protected a lot of people. So this used to happen, but now this was like kind of normalized, because we are doing agile, we need to be on our toes all the time, and changing requirements was frowned upon when in the waterfall mode. But right now, if there is something new, something urgent, then with the agile mindset in place, we know we have everything prioritized. So we know what to drop right now, what to pause at the moment, and take up something new, jump on it, put all our efforts into it, and then ship it out. That was what the agile mindset is. So this was what the perceived benefits were. Okay. Everything clear till now? You have any questions about anything till now? Yeah. I hope I'm not going very fast. Because there's not a lot of technical things. It's just about the way of doing things, which is what I'm concentrating on. All right. So how did we bring about those changes? It was automation, automation, automation. So we needed to make changes across the entire development, testing, and release systems. There were a lot of manual processes in place. Trust me. We needed to automate every single thing. We needed to reduce the manual effort and manual interaction, because they would be the points of bottlenecks. You develop, and then when you not using continuous integration, continuous development pipeline, it just becomes like you compile it on your own, make a DLL, put it up somewhere, and then it gets compiled in like few days, and then then you get a build with the entire thing. Then you send it out for testing to the QA people. Like there are a lot of bottlenecks, so a lot of manual intervention involved in getting the piece of code, like few lines of code you'd written, into a finished product which you could actually deploy on an OS and test it out. So the main focus was on reducing this, and for that we did a lot of automation. We introduced a lot of new processes and workflows to reduce the manual effort, as I said. And for automation of these user scenarios, like I said, user clicking, launching the exe, selecting maybe scheduling a scan every 2 months or every 2 weeks, and then closing it, and then checking if the scan is running. So this is one scenario. If a person would do it, he would do it on one OS, it would take a certain amount of time, he'd have to wait, or like set the clock and see if the thing is launching. But once you've automated it, it can just run seamlessly. We'll just be using computation time on the cloud, computation resources, and not actually a person's time. And on the long run, that is like cheaper. So we created a new library from scratch. We did not depend on third party. So it's always a debate whether should you use a third party thing which already exists in the market, which is being used by millions of people, and you just like put it in your entire system and integrate it around it, or should you just build your own thing from scratch. There's always this pros and cons of both the things. So the reason why we went ahead and developed our own things from scratch, what I'm saying is that even a function which performs a mouse click, a user mouse click, we wrote it ourselves in Python. The reason was that in case there's a third-party library which does it, and we need a feature instantly for our automation library, what do we do? Either we go and make changes in the open source library and wait for it to get accepted by the community over there and it getting pushed out in its later release, and then we put it. So there's a time lag involved. Or the other thing is we make the changes in our version of the third-party library. Okay. So once we do that, we have branched out from the main library because we have made the change on our own code base. So at that point of time, we are incompatible with future releases because we have like branched out. So, and the major thing was we are a security company. We don't want any third-party vulnerabilities creeping into our product or our system. A lot of these third-party things, open source things, which are maintained by the public, have a lot of vulnerabilities which keep cropping up time to time. So to avoid all of that, we made our own things from scratch. So if we build it from scratch, we need people to maintain it. Okay. So a new team was created out of mostly young engineers, like fresh college grads and recent people, to develop all these necessary automation libraries and also the workflow, the processes, the build cycle, the build process, releasing, deploying it on an OS, running it in an automated fashion. A lot of the automation, it was like given to these bunch of new people. It was because new folks, they won't really be as averse to, how do I say, okay. These people have been doing waterfall, the people who have been around, they have been doing things a certain way, and they would be very averse to change because they're doing something for like 10 years in a certain way. They know, okay, I'm writing a feature, now I can like pass it on and I can like work on defects or I can do something else. When the other person is done with his part of testing, then he'll come back to me and then I know, okay. So he has certain, his way of working, his working style is like fixed. So what we are doing is we are not developing a feature right now, we're not developing the Norton product, we are developing a parallel system which would support the testing and development and the release cycles of this. So these senior folks, they would be required for developing the product and they were working in a certain way. When we bring in new folks, we're building something new, so they won't be as rigid and everything is new for us, right? So we could just jump into things faster and maybe out of experience, the senior folks might say, oh no, we don't need to do this or this is not required, like just because like they have seen things happening a certain way. But as new people, we are like, we don't have that experience, so it is good, but it is in a certain way that we'd end up trying something and we might come up with some solution which someone might have said, oh, this is not possible, like let's just not do it this way. I had seen this happening 5 years back and these guys tried it over here and it failed. So if someone has it in mind and they try to, even if you tell them to do it, they might not put in all the honest effort because they know things might not go that way, they have seen it. But if you pull in a new guy and then tell him to do it, even if it's impossible, they'll put in all the effort and try it out and then try it extensively. So that's why we pulled in like new people. And so we have a lot of backlog, we have a lot of automation to do. It's not, if once everything is in place, we will see all the benefits. But reaching there was the main goal which the new team was assigned. And yeah, so how do you, so this is a new thing, right? How do you gauge how the teams are performing? Previously, it was just the defects, the percentage, the turnaround time for defect completion. So we have like some defect, some bug which is reported or like, it's lying in the bug backlog. So how do you gauge the performance of team? How fast they are fixing those existing bugs, how fast they are putting out new release, like those kind of things. How many features have they put out? And then existing automation debt, how fast they're clearing. But now we have a lot of these automation things. So we are like moving away from a lot of these metrics. We're adding new metrics of gauging the performance of these Scrum teams. Things like percentage of test cases automated, code coverage. Do you guys know what code coverage is?
How much of the code has been covered by unit tests?
Yeah, so by unit tests, and so we introduced it. It's also not just the unit test, it's also automated tests. So an automated test would interact with the code base in the sense that from an outside perspective, you launch a UI, you double click it, but in the backend, in the source code, there are a few lines executed, right, which involve launching the exe, minimizing, maximizing the functions which are implemented, they get executed. So we are testing the coverage, we are measuring the coverage, how much of the code has been covered by automated tests. Once we reach a large percentage, then we can say that, okay, we don't really need to do manual testing for these things because all of this code is being touched by automation. So how do you measure that? We have new metrics. And to measure all this data, we had like new data aggregation and visualization tools. Okay. So yeah, adaptation issues. So the new team is developing the automation framework, the automation test, all of that is being done. But there's no QA team involved right now, right? Everyone has been like split across. So the current developers who till now were only developing new features and fixing old defects, now they have added work. If they're developing a feature, there's no QA who's gonna do the manual testing after a few months. So while they're developing, they have to test them manually until the test cases are automated. We went in with the thing that when everything is automated, we will save a lot of time. But right now, the same people who are developing, they'll be developing features and they're going to test them manually too until that test case is automated. So they're done by the same developers, yeah. And if a new feature is introduced, right, something new, something change in the UI, so we have new test cases. We have 8,000 existing cases, but as we have new features, we have new test cases, right? So who's going to test them? Who's going to automate them? You got to automate them. You got to allocate capacity to automate them, to create new scripts which run those things, right? So that has to be done by the same developer. So previously, a developer would just write code and fix defects. Now they will write code, fix defects, test the thing manually right now until we have automation. They are the same people who are going to be doing automation, and then they also need to create new test cases and automate them, right? So you can see like it's kind of an added burden without because everyone is, that's what agile kind of thing. You need to be cross-functional. You need to have all the skills, like T-shaped thing. You need to have a broad skill set, and maybe one of them is your expertise, but you should be okay with doing everything. So that came into the picture, and so developers have kind of added more responsibility. I wouldn't say added work in the sense of like time and effort, but they have to like take care of like a lot of things more than what they were before. Okay, and yeah, there was a huge push by management to complete the automation backlogs fast so that the benefits could be realized soon. Okay, we know that when everything is in place, the entire automation is in place in that ideal state, the developers could just run the code, deploy it, and then go home. The testing would take place automated fashion, and if there are no bugs, the build would be generated and it could be just put out of the release. There's no intervention involved after that. Okay. That is the ideal case because everything is already automated. But right now, it isn't the case, right? So these people are doing it. So yeah, there was a kind of clash that, okay, the manager is asking us to do more work now. What's going on? And senior developers, right, who have been doing things a certain way, they've been like developing security features. They have like extensive knowledge of C++ and Windows internals because our product runs on that. And now they have to learn these new Python libraries, which are being maintained by a bunch of youngsters, right? We developing things, and so they need to get familiar with that. They need to use them in their day-to-day working. Okay, so their existing knowledge, which they have amassed over 10, 20 years, we're certainly asking them to learn something new and adapt their working style to something which is like new. Okay, so that created a lot of friction. So yeah, it is still going on. So we thought it would take like 2, 3, 4 years, but it's like we can't completely do DevOps and automation, like keep building the solution, because we also have the code to maintain. We also have features to ship out. So we need to balance things out. And people would prefer putting out features because that seems kind of interesting to the senior folks, and this is what they're comfortable with doing. And this is something new. We know that the benefits will be realized somewhere later, but not everyone wanted to do these things. So that any change was like it's not easy, and there was there will always be resistance to any sort of change. Okay. So yeah, I'm just talking about the issues we face. The frameworks and tools which we were developing were kind of unstable, and then it was like, as and when people use it, they would be the one reporting bugs, and then we would go around and fix it. But they're dependent on it, so the thing is not completely developed at first, right? So you can see like a chicken and an egg situation there. Yeah, we developed something new, we put it out, the people used it, and then they found a bug, they wasted a lot of time. They came back to us, we fixed it, and then gave it ahead. But this time has been lost, right? The developer, he did everything on his own, completely fine. But he interacted with this system, this new thing, this new tool, which had a bug, and that caused like a lot of frustration, wasted efforts, which if everything was in place already or something, we could have avoided that. So in the end state, there should be no friction. But right now, there's a lot of issues. And yeah, the entire transformation would take like 3 to 5 years, as we can only allocate a certain percentage of the capacity for automation of existing backlog or automating new test cases or manually testing them as and when we are developing new things, right? Or for every release. Like 30 to 50% was the maximum we could allocate, because as we said, we are a product company. We have releases to ship, we have features to bring in, we have competitors coming out all the time. And each of these new things which we are creating now also need to go through the automation kind of thing which you also have to develop, right? So we could allocate only 30 to 50% of the capacity maximum on like good days or like good sprints or good PI to complete the backlog. Okay. The developers started hating the term automation and DevOps and Agile. As you know, everyone was pushing, everyone's saying, you know what, just like struggle for right now, just push a bit, and then at the end, you'll be seeing a lot of benefits and you'll be having a happy life. But like right now, we're facing all these issues, right? And then it just like we can't see a clear end. We're finding a lot of these bugs, these issues, and we have to fix them too. So yeah, everyone wasn't really happy. And yeah, we had like agile manifestos put on walls everywhere so that people get to familiarize with it and then see the values behind it. And we had like we had Scrum teams made, so Scrum masters coming in, daily stand-ups, regular meetings, like whatever the agile ceremonies they would call it, would happen, all of that. And once you see, okay, there's a new change coming in and there's a lot of, that's causing you to go through a lot of pain, even if there is something good you see at that point of time, they kind of become averse to it. So, but what happened was that after a few times, we started seeing faster releases and reduced testing efforts as automation reached a stable state for certain features. So not everything could be automated at one go, but the main things like the scans or new features like the webcam protection, these things, people worked on automating it, like we made out a plan. These features are being developed, but we'll also be automating it. So it was like when we saw that, okay, we developed a feature and within like 1 sprint or 2 sprint, it is out in the market in a stable state, not causing issues, we just started to see the benefits, which was really great that time, because till now we haven't seen that thing, and it just started to like coming up. It's like you planted a seed, it's growing, it's going down, putting out its roots, and then you're not seeing any fruits out of it. But then once you slowly start seeing it, that's when people started like, oh, this is really great. Yeah, we did suffer, but we are seeing the benefits now. So that started getting around a change in the mindset, and people saw the fruits that in the future, okay, this is actually thing. It's one way to say something that, you do this and afterwards you're going to see a lot of benefits. But when you actually get a little bit and you actually experience it, that's when you realize, okay, wow, this is something which is like really cool. So yeah, that was like the cost benefit kind of side of it. Yeah, just so I'm going to conclude right now. What I'm saying is that every organization does agile and DevOps differently. So there's no one right way for everyone based on their internal team structures and processes involved in release. So we couldn't like copy what McAfee is doing or Kaspersky is doing. Just because something is working for them does not mean it will work for us. All right, we have like a lot of outside experts coming in, because the people who designed all the changes in the hierarchy, the organizations, because we were not doing agile, we needed to get in outside experts, and they brought in their views. No, you're doing it this way, you're taking 5 days for it. This could be done in half a day. But I mean, it is a very alien thing, and you can't really tell it to someone that, this process is slow, the entire thing is redundant, just because it is working in a certain way in some place, and that might not exactly fit in how we are doing things. So a lot of the translation from the values and the managerial side of it into actual technical implementation, I think that's where the main challenge of agile and DevOps is, like getting it translated accurately and seeing the benefits out of it. So you can't just take a textbook, see, okay, we do 1, 2, 3, and then we'll be seeing benefits. Every place you'll see different challenges. And yeah, the true benefits would only be realized at the end of the transformation. Sometimes the cost involved would be greater. As we saw initially, we thought, okay, the benefits are not being realized, but it is good in the long run for everyone to like move on to it. Yeah, so that's where my talk ends. Yeah.
Any questions for Suraj?
Yep.
Right.
Question. Can you expand what you mean by the last point that sometimes cost involved?
So we started out with many, how do you call it, initiatives and small projects where we would reward people if they would find some sort of existing process in the entire flow, which if we automated, we would save time. Okay, we would incentivize people like that. So people started looking, okay, there are these existing dashboards which takes a lot of time to load, or this process of pulling down these files related for this a certain test case, you might need some sort of virus and threats. So if someone is executing them manually, you need to download those things from a server and put in your credentials and then make sure you get like just the threat which you want and then you deploy it. Okay, so there is a process involved. Before someone tests it, you need to go through this. So we're like, oh, why don't we just automate it? We'll just go ahead, write a service. The moment you just launch your test case, all of this would take care of in the background. You just get it automated. So it seemed like, okay, yeah, this is a good idea. But then these things depended on a lot of other parts, other functionalities, other aspects of the code. So if you put in a new system, you have to make these changes propagate across everywhere, because first of all, we're getting something manually. Now you're getting in an automated fashion, and you're touching the existing code base. So you have to like make changes to that parts of the code which were previously not being touched by this new process. When you do that, you need to make sure all of these things are tested extensively. All right, so you developed a new tool, put it in place. It is interacting with a lot of other systems. So wherever there's interaction, wherever there's new, there is a possibility of a new bug or something being introduced. And you can't really spend a lot of time making sure this new automated system is working perfectly, because our main thing is shipping out the product. We built a new product, built a new tool, the idea is good, but if it is interfering with a lot of other existing systems and causing a lot of crashes, so you need to set a number of people to maintain just that small thing, right? And in the long run, okay, we'll see, okay, in 3 minutes or 4 minutes, we're downloading all the files we need in an automated way. And it is fine, but we did not see like, okay, because of these versions, software versions it is dependent on, we need someone to upgrade it whenever there's a new version of the third-party library, whatever they use. So there'll be a developer cost involved every 2-3 months, and then a tester cost involved too, to make sure periodically the other system change, so how this thing is interacting, there's no crash involved. So it just isn't about developing, it is also about testing and automating the new thing, right? So the cost involved over here was developing was like one, maintaining it and periodically testing it, right? So it seemed like more effort, and we would just like not automate that part if it's just a very small thing which anyone could like the existing process would take care of. We wouldn't see a lot of difference.
So would you guys like eventually abandon something like that then?
Yeah, so all of these were, so we had like innovation events like hackathons where we would give people like 2-3 days to like, they won't be doing the normal work, they'd be focusing on this completely, and they would come up with a lot of ideas, which was good. They would build a small prototype and test it out with like a very very small set of resources and just give a proof of concept. So we have like a lot of proof of concepts, and things could potentially improve, like, they're in the same, we are automating things. But then when the proof of concept is not the finished product, right? The MVP might not, so when you develop a proof of concept, you don't really regard, you're not developing the entire thing, so you'd be like not working it as thoroughly. So in theory it works, but then there's a lot of testing and other development effort which would be involved. So we just left it at them, yeah.
All right, thank you.
Yeah.
So, let's see. This is what I sent out. Let's think about the talk we just heard. There's a few things that I'd like to emphasize. One is that this is being driven by the fact that people realize other companies are responding faster to customer needs than they are. Symantec's a very well-established company. They've been around for decades, and they're being motivated to change their process because they see other people going fast. And as I pointed out, the virus creators don't use a waterfall model. They don't wait for the new virus design document to come and then code it up and then hand the new virus off to their QA department and have them test it for 6 months before they release it. So if you're on that kind of cycle, they're going faster than you are, right? And this is happening in financial markets. People are realizing other companies are able to put out new financial models faster than them and respond to changing market conditions. And you could imagine if your doctor did a waterfall model. You said, you made an appointment and they said, okay, what are the requirements for this visit? I said, well, doctor, my ear hurts a bit, and I got something itchy on my foot, and check that out. And you get in there, and the doctor starts doing that. And you go, doctor, I'm having a heart attack. And he says, well, that's not on the requirements document for this visit. So we're going to have to push that off to visit 2, which we'll schedule in 6 months. So, you don't get good customer response with this kind of model, right? The other thing that's important is that, Carol, phone away? Thank you. The other thing that's important is you're going to be a beginning software engineer. You're going to get someplace and be early in your career, and there's going to be people who've been around for a long time. Some of them are going to be adaptable and flexible and say, oh yeah, this is a great idea. Sometimes they won't be. It's early in your career, it's important to be gentle and suggest, hey, maybe we could automate this. One of the DevOps principles is find the place, what's causing you the most pain right now? What's the worst thing your company does? Oh, well, whenever we release a product, I had someone who's worked with some of our projects get his first software job at a company that was very wonderful, and I said, so what's up next week? And he said, well, I have to go to the customer site. We send like 10 engineers to the customer site for a week because we release new software. So they knew it was just going to crash repeatedly whenever they did a release, right? So here's a point of terrible pain. These people were going to work 60, 70-hour weeks. They had to travel to the customer site. The customer hated it, of course, because their software is crashing all the time. So just maybe we could do something so that our releases were a little more stable when we put them out. What if we did this? So if you introduce this stuff gently, you'll have much more success. If you come in, fresh out of finishing your degree and you go, well, I know all about DevOps, let me tell you guys, and these people have been there 10 or 20 years, they're more likely to dismiss you than listen to you. And so you have to realize they do know stuff, right? They may not know, you may know some stuff they don't, but they know some stuff you don't, and you have to kind of work gently. If you slap up agile manifestos in their face everywhere, they may resent that a little bit. Let's try to do a release. So we have our projects. I think everyone's on a project, or if not, then get on. I think last I saw there was like one person still not on a project. Hopefully they got on one. And we've got nice real stuff we're doing. NYU has an emergency response center, and we're going to do a project for them where we're going to try to put up a website coordinating so people can get emergency alerts about a shooting that happened somewhere or something in real time and get updates. This is real stuff. We're going to do something for New York City. It's a real project. This should be great for your resume, right? Because you're able to say, no, I just didn't do like little school projects, people tend to dismiss them. No, I worked on these actual open source projects, other people use them. But hopefully also, it motivates our use of these tools, right? Because if we're just doing a toy project, why do we need extensive testing? Why do we need to monitor it? It's just, just an exercise we're doing for school. If it's software people are really gonna use, then we do need to test it. We don't want it crashing. If people are looking to our software for updates on a shooting, well, we don't want it crashing when they're trying to find out what's going on. Oh, why, thank you. The light goes up top. All right. This is a reason that I try to set up the project like this. This week we have to try to get completely set up so whatever project you're on, anytime you start somewhere, the first thing you have to do is learn how do they work here? What tools do they use? How do I get going? How can I say hello world within the context of this system, right? And it's always going to be different. There's always going to be challenges. The worst part of a software engineer's life is setup, installing, right. So Dennis was around all summer, and he knows this. I had gone back and done some graduate school. My kids were very little, and they hadn't seen me doing software engineering. Then I started again, and I was trying to, do some Linux installation or something, and I'm sitting at the computer going, and my kids were like, Mommy, what are those words Daddy's saying? I said, well, those are special software engineering words. They seem to all have 4 letters, but they're technical words that Daddy says whenever he installs software. So you're going to have trouble, all right? And I apologize, but this is the way it is whenever you're trying to get a setup working. There's trouble. This doesn't work. That doesn't work. It's unfortunate. It's part of our job. If you say, I hate dealing with this kind of thing, and I just don't want to, well, it's like you hear from a plumber. Well, I hate pipes and water, but I want to be a plumber. Geez, if you hate pipes and water, maybe that's not the right job for you. No one has fun doing the setups, I don't think, but we have to get so we can master it. The big thing is persistence. You keep going. You hit a problem, you Google it, you look on Stack Overflow, you ask other people, what did you do? You read the instructions again, you try something else. So you're going to have trouble getting your setup working. And we have, at this point, a fairly sophisticated setup. We try to keep it toned down to the point where it's not more than we need. But I want to walk you through what developing something in one of our systems is typically like. Some of these projects are brand new, and we'll have to set this stuff up for the project for the first time. So the emergency response system, there's nothing. There's 0 code, 0 tests, 0 tools. So you should look to the other projects and say, okay, how did they set up this stuff? How did they set up testing? How did they set up builds? The existing projects, you're going to come in and hit this set of tools, and luckily then there'll be people around who hopefully can guide you and show you what's going on. So let me walk you through what working in one of these systems will be like, and then we can, I'll go back to this document with the set of things, and I think it'll be more comprehensible what we're talking about when you've seen it. Okay. It is important that you have access to Unix development tools. If you're on Windows, you can get Linux subsystem. There's Git has a bash version for Windows, so you can get these. The set of command line tools under Unix, so Unix means Unix and all its descendants, Mac OS and Linux, right? So Unix was the ancestor operating system at AT&T Bell Labs. Mac OS is essentially a version of Unix. Linux is essentially a version of Unix. Windows, with Windows PowerShell and the Linux subsystem, has embraced this. I was at a DevOps conference and this woman was speaking. She said, I actually got hired at Microsoft and they told me, we need you to promote the use of Linux. At Microsoft. Her job was to promote the use of Linux. She's like, what? You want me to do what? They said, yes, promote the use of Linux. So, okay, that's what you say. Microsoft has realized that Microsoft at one point was saying, oh, you set up your whole system with Windows, point and click, fill this box in. And that's great when you're setting up one server. It's simple. You don't need to understand a language or anything. But now in the cloud, people are deploying 1,000 servers. And you're going to point and click your way through setup for 1,000 servers? No, you need a script. Automation is the only way to do this repeatedly for 1,000 servers. If you tried it manually for 1,000 servers, you'd be so bored you'd be forgetting stuff, right? That's what happens when we try to give humans the boring jobs that should be automated. They get bored, right? And you get sleepy, and you're like, oh, yeah, okay, yeah, I got it. Okay. And after a while, you're making mistakes, right? Give the boring automated jobs to the computer, right? It never gets bored. So we want to automate this stuff, and it's command line tools and scripts that allow us to automate it, right? Because command line tool, we can put it in a script and call it from a script, right? It's very much harder to have a script click on a checkbox, right? It's not impossible, but it's a lot easier. So you need to know these things. With our version control is Git, right? And we store our repositories on GitHub. You're welcome to use GitHub Desktop. That's fine. But you should at least be familiar with the command line way of working with it, because sometimes you're going to need to go in at that level anyway. So let's try to change something. And watch what happens as the change goes through. So I'm going to do, let me do the full command. I have aliases. I'm going to just do a pull and make sure I get the latest, which I did not have. All right, we have a whole bunch of new stuff. We serve our static websites from GitHub pages, which you just turn it on your GitHub repo, and it serves it as a website. This is great. It makes it easy. You can put up as many free websites as you want. It doesn't have any back-end processing, right? So typically, if you're doing a web app in Django or Ruby on Rails or Flask, it gives you the ability to include stuff. So you have uniform menus and this logo that appears everywhere and the same style sheet pulled in. What we did was we made some processing on the front end on our development machine that allows us to do that for a static website. So for instance, we get the uniform menu across every page by including it on our side. To that end, different projects, in general, we want to have what's called a Git submodule called utils. Utils is a bunch of utilities that allow us to do things like do an include into an HTML page, change an HTML page into a Django page if we're already developed it in HTML and want to convert it, to do tag checking for our HTML. We've got things to turn C++ code automatically into web pages for class use. A lot of utilities. So there they are. It's a Git submodule. Let me show you this in Git, on GitHub. The evidence, well, the easy way to tell this is a submodule, an easy way, is we have a whole bunch of folders in this project, and they all look like folders, except this one. This one, it looks like a double folder, and it says it's at something, right? This is a separate repository for the utilities. We've got this set up in scripts, hopefully for your project. If not, it's a new project, you'll have to create it. But you do git submodule add and add a separate repo into your repo, and now you've got these utilities available. And you should do this for your project because we've got all this stuff and we know how it's used. We can help you use it. We can tell you how to fit it into your process. If you click on utils, you will see that we went off to a totally separate repo, right? gcala utils. So, whereas, if, for instance, if we click on HTML source, we're still in Indra's net, right? HTML source. That folder, we're still in the same repo. We clicked on utils, we went into a different repo. It's a submodule. They're a bit of a pain in the neck. Someone on Stack Overflow called them sob modules because they were making him cry all the time when he was trying to use them. So they break, they're a little bit fragile, but they are useful. So we can share these utilities across multiple projects. So I am going to edit a file, and we have HTML source, which has, for our build utility, which I'll show you in a second, we need a different extension than HTML because our build utility looks for files of one extension and turns them into another. So when we have something that we're going to build in our development environment, we automate that. And we automate it with a build tool. We use Make, which is a standard Unix build tool. It's been around for a while. It's free. It works with any language. There are specialized build tools for Java. For instance, there's Ant, I think, is a Java build tool. Maven is a Java build tool. So there are specialized build tools for different environments. This one works across languages. It's free. Your professor has worked with it for a while, so I know it well. That's an advantage of it. So let's add a contributor here, right? Okay, so we know John Knox is working on this. So now we've made a change. And I'm deliberately making a very simple change here. I'm not going to try to do some fancy coding right now off the top of my head to change our main server or something. I just want to show you the process of I've changed something. Now what do? We have a make file, and all this is we're going to go into in more detail. The make file sets up a bunch of variables, but the core of the make file is a number of targets, things that we can build, and then a potential thing that the target depends on. In this case, it says any HTML file depends on a PTML file in the PTML dir and some includes. And here's what we do in order to build it. This is just a list of commands. This is an example of a domain-specific language. This is a handy idea. People do this. We have YAML as a configuration language. HTML is a domain-specific language for marking up web pages, right? You can't write a general application in HTML, right? You need to supplement it with JavaScript, for instance. That's why people do it all the time. But it's a great language for saying how to mark up a web document, a web page, right? So Make is a specialized language for building things, for building software things. It can't build your house for you or give you a new bathtub in your bathroom, but it can build software for you. In particular, we try to say everything that we're going to build, like our development environment. Let's put that in the make file. So this, if you're working on the Indra project, this would help set you up. if you're working on one of the other projects and it doesn't have something like this, we should put it in a makefile so that when we bring new developers on, we say, oh, create dev-env, that'll build your development environment for you. So as much as possible, automate, 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 right? And why? Because this headache of setup, to the extent we can automate it, the headache goes away, right? The more we automate this, the less setup headache we have, and it's more fun to try to figure out how could I automate this than do it manually again and again. If it takes me 5 hours to automate something that would take me 5 hours to repeatedly do manually, I'd rather do the 5 hours automating it if it was a tie, right? Because that's more interesting. I learn more, right? Learning that, oh, this needs the -m flag if I'm going to have it run right. Well, that's a piece of knowledge I need once. If I figure out how to use the build script cleverly to build this, or what shell script, or what shell command can help me, now I know something new the next time I want to automate something. So even if it were a tie, over the long run, I would take the automation anyway, because you learn more, it's more interesting. Typically, it's not a tie once you look out a little ways. A month out, 2 months out, the automated method is saving you time. So I just changed one of these PTML files. Again, that's just a made-up thing we did so that it had a different extension than HTML. We had to give it something. So pre-HTML was what we were thinking of. There's a few of these that had to be built. That's interesting. I just changed about. It may be, that's something I'm going to check into, why there were so many things that weren't built. But what it did was it followed the commands I gave it. It ran an HTML checker that checked for tag consistency. We also have a spell checker. We should probably put that in this process. So we're already doing some QA, right? Just in the process of making the HTML file, we're already checking. Let me show you, let me screw this up. Let's do this. Right, now we have bad tagging. We have a list item tag that's not in a list, and it doesn't have a close, and the matching close is an H1 tag, right? I'm just going to run it from inside my editor. Oh, H1 tag does not match open tag LI at line number 15. So we've done QA on our thing. We screwed up our tags. Our process caught this, right? We get rid of it, and we can make local. When working from the command line, you want to take advantage of the automation you get from the command line. You can up arrow to go back through commands. You get tab completion. So completed make, that didn't save me much time. Now that I've seen that it builds locally, if it was anything more complex to the page, I would actually take a look at the page locally. Since I just added one name and we want to move fast here, I'm not going to pull up the page. Now we're going to make production. Your project should have a target called prod, just because standardizing these names makes it easy to move from project to project. If we run out of work on one project and another project has tons, well, we want to move people, right? The more the projects look and feel alike as to how you work them, the easier it is to move. If everyone has a different name for this step, well, you've got to remember that name. You're going to type this by accident because you've been using it for a few weeks. So this, so I haven't built from here. Okay, so sorry, I should have run a build from here. Oh, -R. Sorry. It's still, okay. This will install everything. So there was something I didn't have installed that's necessary to build, but we have all of our requirements in text files that say what is needed so that our different tools, when we want to run this somewhere, we can just do an install of the requirements file and not worry about remembering what each of these things is, right? This is part of the automation idea. We don't try to rely on people to recall everything you need to install. You keep what you need to install in a file, and hopefully, okay. Now we're running automated tests. So that's interesting. Could not open menu file. So now we have some debugging to do. So we're lacking a menu file. So the path has to be wrong. I know what I don't have. I don't have. So hopefully this will be right. So export. Need a slash on the end. Let's try it with a slash. So I forgot that I had not built on this machine previously. Cannot open menu file. Let's try, we'll try one more thing. And we'll try a different project at that point. We'll try it with no slash on the end. All right, well, so the environment is not set up properly, and therefore our build is failing. But this is what happens when there's a problem in the build. It stops, and you don't. It doesn't go any further. When something fails, will stop your build. Let's try something where I know the build will work, and we'll look at what happens with that. MISC, and we have complex struct. Okay. Is for okay. Added. So we ran some tests, many fewer here. And now it pushes, when you do make prod, when the tests work, it pushes to GitHub. The push to GitHub will trigger, you want, okay. Travis CI is a continuous integration, continuous development tool. It watches GitHub, and we'll see here, less than a minute ago, it detected the fact that I pushed to GitHub on this project. So what it has is a webhook. So we need to set it up. If you have a new project, you need to set up a webhook from Travis to GitHub. And when it detects a push, it kicks off tests. It builds a virtual machine for you on Travis. This also uses the requirements file, and it's going to install everything that's a requirement for us. These are green when they work. This one is red. This is not in use at the moment, but we should see. This means the build on this repo failed the last time it was run, 3 months ago. We'll have to take a look at that and just clear that up. But when the build succeeds, it goes green. This is not deployed in the cloud anywhere, because this is just a class website. But when we have a server we're deploying to the cloud, let me show you another specialized language file. Don't want to update profile right. Okay. Travis itself is controlled by a script. So we don't configure Travis itself by pointing and clicking on things. We have a Travis script. That script itself is under version control in GitHub. And what Travis does is when it sees the push, if you have a webhook, it reads this. This is a specialized installation language, configuration language called YAML. And we set it up. We say that this product is going to use the Python language. We want to test version 3.6. We can test multiple versions. We're going to employ the Docker service. Before install, we're going to install some encryption keys. Once that's done, we're going to pip install all our requirements. So the thing I did to pip install those requirements, Travis uses it as well. Docker will use it as well. So we keep our requirements in a text file, and everyone who needs to set up this environment, where everyone is any of you, but also programs like Travis and Docker, sets it up from the same source. We can then set environment variables. So we set Python path, propster. And so these are the things that weren't set up here properly, so I could run the build for Indra. I apologize because I thought I had run the build here. So I didn't check. Always check before you do a demo that your stuff is working on the machine you have. Then it runs the same make tests that we were running locally. It runs them here on the Travis server. Why do them twice? Well, sometimes developers are tempted. I just made a little change. I'm just going to push straight to GitHub. I'm not going to test. The testing takes too long. The tests will run anyway. And only if the tests pass, only if they pass after success, then we deploy to production. So this is our cloud deployment. So our main cloud service now is Python Anywhere. This logs into Python Anywhere, pulls the code from Git, and then reboots the server to use the new code. So our deployment is controlled by the passing of our tests. And then we also build a Docker container at this point, so that if we want, we can also deploy it as a Docker. Docker is a packaging tool so that you can package all of your Python modules, any database you're using, your file structure, your environment variables, all into a Docker package. And this is a complete runnable environment that runs under the command of the Docker server. And once you've done this, you should be able to run that container locally and have an identical environment to what you deploy into the cloud. So we also build a Docker container, so we're ready for Docker deployment as well. Okay, so having had a look at what is going on, let's just review this here. Take a quick look at this too. Besides the code being here, we also track our projects on GitHub. We've got Kanban boards. This is Kanban boards come from Toyota Production Systems. Why is it not scrolling? Oh, maybe there's nothing, no cards here yet. Well, we'll look at this one. We know this one has stuff. Why is it? It may be a feature of the fact there are cards under here and it's not scrolling down to look at them. Well, we'll bring a different machine and we'll show you the Kanban boards. But Kanban boards are common use. It's Symantec. We're using Kanban. Yeah. Yeah, okay. So a key thing is to make small improvements regularly. This is crucial in many ways. First of all, you make a small improvement, or what you think is an improvement, you can get rapid feedback. You show it to the user, and sometimes the user goes, what? That's not what I was thinking of at all. No, you totally misunderstood. You find that out right away, rather than in a year or in 6 months, right? A small improvement is much less likely to have bugs. And if it has bugs, you know right where they are. So you put out small changes, anything's wrong, you just look at those few lines of code you changed. And small changes allow us to actually monitor that, it makes work visible. That's a common DevOps phrase. We want to see that progress is being made. In the Agile Manifesto, the best measure of progress is actual working software delivered, right? I was talking with someone at a major bank, and she told me that, oh yeah, we have a new system coming out next month. It's going to be on the web. It's big things with our sales stuff, and it's going to allow us to track customer contact, and they swear it's almost ready. I said, oh, so they've been posting new versions all the time and letting you look at them? And she said, well, no. I said, it's not ready. It's no way is it being delivered next month. Forget it. 6 months, a year, maybe. And it was true. I don't think it's still fully delivered. If someone, and this is what would happen in waterfall projects, if they led to a joke, all software rapidly becomes 95% complete and then stays that way forever, right? People would say, oh yes, we're almost done, but they had never delivered anything, and you couldn't really tell. And they might, it's not necessarily they were lying, they really thought they were, but if there's nothing working that you can use, you don't really know how far along you are. Make small working pieces of software and put them out and allow people to use them. It's the idea of a minimum viable product, right? We try to rapidly get a minimum viable product that at least people can click on and see what our idea is, and then add improvements in small increments. Everything should be on a Kanban board. Our discussions are on Slack. People have used Slack. Do you know what the name Slack is from? Slack, this is another DevOps principle. The name of the product is a DevOps principle. When you have a project, you need to leave some slack in the project. If you schedule your day back to back to back to back, what'll happen? A, anything goes wrong, the whole schedule's off. B, you don't have any time to think. And a lot of times your best ideas come, you're staring out the window watching some clouds. And you go, oh wait, I can do this way, that'll be better. If you don't have any time to do that, you don't have any time for those little creative insights. So that happens to be what the name Slack comes from. Build should be controlled with a make file. We should have automated test coverage. You should write tests as you go along. There's actually something called test-driven development that says, first write a test, and then write code that can pass the test. The extreme is only write enough tests that it fails, then only write enough code that it passes. So you actually wind up just trying to call a function that doesn't exist. That's your first thing. And of course it fails. And then you just write the function name so it passes. Then you add a little code to the test to see what it's doing, and it fails. Then you add that little bit of code to make it pass to the function. It seems like it would be torture to do this, but it actually means you're always, Bob Martin, famous software consultant, says, you're always within 1 minute of having a working product if you actually use this method. We want to deploy through configuration files and scripts. We want to have regular code reviews with each other. Look at my code. What is this okay? With your project leader, with me when you can. One of the things as a software engineer you should take on is you want to get egoless about your code. Never defend your code because you wrote it. You want to be open to correction all the time. And the best people are the most open to being corrected. It's like, oh, I can do this in n squared time instead of n cubed. Great, show me how. That person is always going to keep learning, right? Someone who goes, well, my way was fine. I don't know why you're coming here telling me I don't know what I'm doing. What have they done? They've blocked themselves off from learning, right? So if you get defensive about a problem in your code, you're blocking yourself from learning and improving. The people who keep learning and keep improving just say, hey, any idea is, if it's better, I don't care who it came from. And people who have worked with me will know that if a student says, professor, you did this wrong, this is better, I go, oh yeah, you're right, thank you, that's good. The fact that it was a student, I don't go, oh, I'm the professor. Who are you to tell me that? You want to get that attitude so that way you're always learning. Linting, you may not know this. Let's just look at a quick lint run. I'm supposed to be somewhere else right now, so I'm being a little naughty. We have faculty meetings, but faculty meetings are snooze fests. So I'm going to hang out for a minute more. Linting is, what one is not going to pass? Don't we have something bad here? How about height? No, height pass. Wolfram, wolf sheep. Let me show you, how about flocking? Maybe flocking won't pass. Oops. Let's make a mistake in flocking. Okay, let's say I do this, okay? My indentation is wrong. Lint tools clean up your code. Lint is the little fluffy stuff that you find in your pockets when you take your clothes out of the dryer. And the original lint tool was for C, it cleaned C code. It was called lint. So we call them all linting tools now. We use Flake 8 for Python. catches style errors and things that are uninitialized. Very good. It's another way of ensuring our code quality. Write good commit messages. You are communicating to your team members what happened. I've sometimes seen commit messages like, I made a change. Well, yes, that's why there's new code. That's sort of, what we know happened because there was a commit. Yes, someone made a change. But if all of a sudden something's broken, right? We want to know who was working in that area, what happened, what changed, right? I made a change to the Travis configuration file to set up the new environment variable X. You don't need to write a book, right? But you write enough so that someone can look at it. You're communicating to your teammates when you write commit messages. You want to write enough that they can say, oh, okay, that's probably not the problem, because the bug I found has nothing to do with Travis. So a change to the Travis file, that couldn't be the problem, right? Okay, this one, they changed the Python file in the library. That might be it. Let me look there. So you want to write nice commit messages. We should trigger tests, like with Travis. We should try to deploy to Docker. Even if our main deployment is Python Anywhere, we should still try to build a Docker container so we have an alternate method of cloud deployment. And if you're running a server, we should get monitoring for the server so we know if the server goes down or its response rate slows down. Okay, what we'll do, you guys are in, this is tougher with the grad students because they're taking this online, right? So it's hard to get them here. Maybe there may be some here. I encourage them to come if they can. But you guys should try to set up group meetings at the end. We're going to try to just talk for an hour and 15, hour and a half, then have your meetings. We have the room. We have it for another hour and 15 minutes, so meet here. Unfortunately, today I can't stay with my teams because I'm already late. But Tirupal is here. He's got all grad students. Rohit is here. Some people are working with him. Dennis is here. I know some of you are on Dennis's team. And even if you're on my team, at least meet with each other. And we need to collect GitHub names. We need to put everyone in the repository. So my teams get together, all collect your GitHub names, send them to me so I can add you. Some of you are added already because you've come and met me. All right, so I need to run, but you guys should try to get going. And we'll look to start having actual work coming out next week. All right, so this is setup week. Next week, start work.